Alright, hello, assalamu alaikum everyone. We'll do AS trigonometry today. So there are three aspects to it. One is angles, the other is identities, and the third is graphs. Okay, we will discuss identities and angles together, and then in the next video we'll discuss graphs. Okay, so for angles, the first thing that you need to know is you need to understand what are the signs in each quadrant. This is called the first quadrant, second quadrant, third quadrant, and this is called the fourth quadrant. Over here, sine is positive, cos is also positive, tan is positive. Sine is positive, cos is negative, tan is negative. Sine is negative, cos is negative, and tan is positive. Sine is negative, cos is positive, and tan is negative. So this is how it goes, and we go in a anti-clockwise direction. Now, what are the formulas in each? What are the formulas? So the first quadrant may, in the first rotation, 0, 90, 180, 270, and 360. Alpha, 180 minus alpha, 180 plus alpha, 360 minus alpha. This is called the first rotation. Let's talk about the second rotation now. In the second rotation, it is 360, 450, 540, 360, 450, 540, 630, and then it is 720. 360 plus alpha, 540 minus alpha, 540 plus alpha, and then 720 minus alpha. This is called my second rotation. Now, if you talk about the negative rotation, negative rotation is minus 360, minus 270, minus 180, minus 90, and then 0 degrees. Minus alpha, oops, 0 to, this is minus alpha, minus 180 plus alpha. Now, how do we find out the angles? Let's talk about that. For example, if you have sine x, 3 sine x minus 1 equals to 0. This is my question. So sine x is equals to 1 upon 3. A positive sign means first and second quadrant. And it is always given in the question that x is between 0 to 360. That means it's the first rotation. So first we will, step 1 is basic angle. What is the basic angle? You find it out by doing sine inverse 1 upon 3. Basic angle हमारे पास होता है. Basic angle is always acute, positive, and acute, and it is always positive. ठीक है? अच्छा, so sine inverse 1 upon 3 will give me alpha as 19.5 degrees. Now sine is positive in the first and second. So first and second, what are the formulas? It is alpha and 180 minus alpha. So first thing is alpha itself is the answer. Next is 180 minus 19.5 is the next answer. So these are two of my answers. Okay, now let's talk about another question. Cos x is equals to minus 3 upon 4. A minus indicates that you are in the second and third quadrant because cos is negative in the second and third. Now, how do you find out the basic angle? Cos inverse 3 upon 4. For basic angle, ignore negative sign. So how do you go about it? It becomes cos inverse 41.4. Now you need the second quadrant angles are 180 minus alpha and 180 plus alpha. This is 138.6 to 21.4 degrees. These two will be my final answers. Okay? Alright, now next. For example, if you get sin x tan x minus 2 equals to 0. Now, there are two possibilities. Sin x equals to 0, tan x minus 2 equals to 0, tan x equals to 2. Now you have to remember one thing. These are a couple of pointers which are very important. Sin inverse 0 is 0, 180 and 360. Learn these, okay? Next is cos inverse 0, 90 and 270. Tan inverse 0, 0, 180, 360. Tan inverse infinity is 90 and 270. So over here the angles will be sin inverse 0. So you will get 0, 180 and 360. Now totally depends. The angle x is, I am assuming all questions may x is from 0 to 360. Acha ji. So tan inverse 2 will be, the basic angle is 63.43 and a positive tan means that you are in the first and third quadrant. Third means going to be 180 plus 63.43. So that is going to be 243.43. One answer, second answer and these three answers. I hope it makes sense. Now the next question is, for example, if you have okay, 5 sine square x minus 5 sine x minus 6 equals to, it's a quadratic equation in trigonometry. So what we will do is, you will solve through either middle term breakup or you will solve through quadratic formula to get sin x values. Now I am using quadratic formula, but I am not doing the working because I am assuming this is a quadratic equation and all of you can solve it. So I get sin x is equals to minus 0.704 and the next value is sin x equals to 1.704. Another important point to note is that sin x value maximum is 1, minimum minus 1. Cos x maximum 1, minimum minus 1. So you have to reject this value. For this one, alpha will be sin inverse 0.704. So it's going to be sin inverse 0.704, 44.7. Now, negative sign is in the third and fourth quadrant. 180 plus alpha, 360 minus alpha. 224.75. So these are my two answers for this question. Okay. Now so far we've been solving everything in degree mode. Let's talk about the radian mode now. For the radian mode, you know that pi radians is equals to 180 degrees. So the formulas will shift accordingly. Okay, the formulas are very easy. I'm just writing them down. Alpha will remain alpha, pi minus alpha, pi plus alpha, 2 pi minus alpha. Alpha will remain alpha, and I'm highlighting the radian ones, okay? Now over here it will become 2 pi plus alpha, 3 pi minus alpha, 3 pi plus alpha, and 4 pi minus alpha. Over here they will become minus 2 pi plus alpha, minus pi minus alpha, and minus alpha. These are my radian angles, okay? Now let's move on to identities, and then we'll solve the two concepts together. So in identities, the only identity which is apart, cos theta and sin theta are your basic trigonometric functions. Next is tan theta is equals to sin theta upon cos theta. And the identity is cos square theta plus sin square theta is equals to 1. So I can write, how can I switch this identity? 1 minus sin square theta. 1 minus sin theta, 1 plus sin theta. This is one way of writing it. Then sin square theta is 1 minus cos square theta. 1 minus cos theta, and then 1 plus cos theta. Now let's see how to use these identities and how to solve the questions. Okay. Show that the equation, this can be written like this. Sin theta, I'm just multiplying, plus sin square theta minus sin theta cos theta plus 2 cos theta plus 2 cos theta sin theta minus 2 cos square theta. Now, sin square, equals to sin theta plus sin theta cos theta. Let's solve it. If you get minus sin theta plus cos, this becomes a plus cos theta sin theta, and this cancels out with this one over here. Now next is, you have to express everything in terms of cos square. So I'm writing this as 1 minus cos square theta plus 2 cos theta. So I've used this. I'm copying, and I've also used this, minus 2 cos square theta equals to sin theta, and sin theta will also cancel out. So this becomes minus 3 cos square theta plus 2 cos theta plus 1 equals to 0. So if you take the minus sign common out, this was pretty simple. I used the identity in place of this, only the rest was all simplification. Now hence solve. Solution means you first need to solve this quadratic equation. So it will become 3 minus 2 minus 1. So cos theta is equals to minus 0.333. Then cos theta is equals to 1. Now the angles that you have to find out from between minus 180 to 180. So if you look at this, minus 180, minus 90, 0, 90, and then 180. This is alpha, 180 minus alpha, minus 180 plus alpha. Okay, cos is negative in the second and third. Alpha is cos inverse 0.3333. So it will become 70.5 is my alpha. Now negative cos is in second and third. So I will find out these angles. Minus 109.5. These are two of my answers. Now this is positive. Cos is positive in the first and second. First and fourth. Cos inverse 1 is 0. तो fourth वाला क्या हो जाएगा? Minus alpha, which is minus 0. तो एक 0 ही आंसर रहेगा. So this is 0 and 109 point minus 109. These are my answers for this question. Let's move on to the next question now. Now there is a change of range concept as well, which I will explain you through this question. Now the first part is where you have to prove the identity. How do you prove the identity? You open it up. This is a and this is b. So I'll open it up through a minus b the whole square. One upon cos square x minus 2 upon cos tan is sin x upon cos x plus sine square x upon cos square x. There's a cos square in the entire denominator, so that will be the LCM. We can do middle term breakup in the numerator, so it will be 1 minus 2 and plus 1. It's going to be sin x minus 1 and sin x minus 1. Cos square x can be written as 1 minus sin square x, which can be written as 1 minus sin x, 1 plus sin x. और अगर मैं माइनस साइन कॉमन निकाल लूँ 1 minus sin x, this cancels out. You are left with 1 minus sin x. I multiply the minus sign with both of them, which is what you had to prove. So this is proven. See. Now hence solve the equation. Same equation hai, so this can be replaced with this. And in place of x, it's 2x. And this is from 0 to pi. So there are two concepts equals to Vn. Ek to we are doing the radian mode. Another thing is we are doing the 2x thing. Now how do we do it? That's the question. Okay, so first thing is how do we change that? This is 2x. So we will do 2x means 2 into 0 is 0, 2 into pi is 2 pi. That means you will be finding out the angles between these two values. Now, 1 minus sine 2x equal into 3 equals to 1 plus sine 2x. Sine 2x is equals to 1 upon 2. How do we find out the basic angle now? Now my calculator should be on radian mode. Okay, finding it out on the radian mode. Sine inverse 0.5 gives you 0.pi by 6. Now, this is pi by 6 and second quadrant is going to be pi minus pi by 6. That's going to be 5 pi by 6. Now, these are my angles from 0 to 2 pi. And these are my angles of 2x. I need x. So, I'll further divide it by 2. And my next will become 5 pi by 12. Does it make sense? I hope it does. Now let's do another change of range question, which is going to be a little more tricky. Okay. Over here, they want you to show without calculator that this is this. In place of tan, I can write sin x upon cos x. Plus 3 cos x plus 1 upon cos x equals to 0. If I take cos x as my entire LCM, this will go on the other side, become a 0. And cos square can be written as, so over here I've used the identity, okay? Now again solving it with the help of middle or formula middle term breakup, it will give me 3 minus 4 minus 4. Sine x is equals to minus 2 upon 3, and that's sine x is equals to 2. Obviously this will be rejected because you know sine can be in maximum 1, minimum minus 1. So this is, and they have asked you to without using a calculator, that means show middle term breakup. Okay, now, so this has been proven. Next part says this entire thing is equal to 0. So I can write, means the entire thing is equals to 0 is reduced to this. But x ki jagah pe they are now using 2x minus 20. So I will use the same thing. Now this is from 0 to 180. This is x. 2x minus 20 kaise hoga? 2 into 0 minus 20. 2 into 180 minus 20. Yani ke your angles should be between these two values. And negative means that it is in the third and fourth quadrant. So this is minus alpha, then 180 plus alpha, then 360 minus alpha. I think these three are going to be enough. I've also taken the negative alpha because ये negative 20 are. Let's see if negative 20 is even used or not. So this is on again the degree mode. Shift sine inverse. Now minus alpha is minus 41.8. 180 plus 41.8 will be 221.8. 360 minus 41.8 will be 318.2. Minus 148 is not a part of minus 20, so हम उसको reject कर देंगे. And this is will be, these are angles of 2x minus 20. Now add 20 divided by 2. 318.2 plus 20, then divide by 2 gives you 169.1. 221.8 plus 20 divided by 2 gives you 120.9. So these are my two answers for this question. Okay. So I've covered the change of range concept using using a question. Okay, let's take out another question. Let's prove a couple of identities now because we haven't done a lot of identities here. One minus tan square, 1 plus tan square is equals to 1 minus 2 sine square x. This is what I have to prove. Now, 1 minus tan square can be written as sine square upon cos square x. This division sign will come here, and 1 plus sine square upon cos square x. Taking the LCM, you know this entire thing is equals to 1 through identity, and this will cancel out. So this is what you're left with. And in place of cos square, you will write 1 minus sine square. Again, the use of identity. Okay, now let's move on to question 2, which is proving the identity. 1 plus sine x to be multiplied by 1 plus sine x. Actually, I've taken the LCM first. The product will be the LCM, so this will be multiplied with 1 plus sine x, and this will be multiplied by cos x equals to 2 upon cos x is what I have to prove. 1 plus 2 sine x plus sine square x cos square x. Very simple identities. This entire thing will become 1. 1 plus 1 is 2. Let's take 2 common out. Cancels out. I'm left with 2 upon cos x. Okay. I don't think so there's any other need of doing any other question. That's about it. Okay.